So, another Terraform talk. You're not happy about the microphone now? Still no?
No.
It's okay? Okay, good, thank you. So, my starting slide for Terraform is normally to make errors human, propagate errors everywhere. That is what requires DevOps or often Terraform. So to properly screw up your day, this is what you can perfectly do. But we actually want to speak a bit more about the positive sides. So starting with Terraform, so Elastic Hard Terraform, I'm starting with the Terraform part. Who knows how Terraform works and what Terraform does? Who has no idea how Terraform works and what Terraform does? One. Okay, we'll keep this quick. This is you. You have written some code to automate your infrastructure. In my opinion, the greatest thing about Terraform that also sets it apart from something like Ansible is that you have a state, and then you have either no state yet if you haven't run it yet, but then you can plan and apply whatever you want to you instrument from the code. You can run this against many different cloud providers, and then you create something, and you keep the state of this. So anytime you make any changes to your configurations, those will be applied incrementally. And it's what sets it apart from Ansible. Most of the people, how they would write, for example, Ansible would be very run the first command, run the second line, the third line, run every single step, whereas Terraform is much better at knowing what has happened before and knowing the current state. So it knows only the changes to make to move you forward. Which doesn't mean this cannot screw up your day if something goes wrong with the state, but that is a separate discussion I want to skip for today. So that is Terraform in 30 seconds or so, where you have this plan and apply phase, which can, on lots of different providers or services, create the infrastructure that you want. You have encoded it as code, and you have that state. And you generally write it in HCL. Who likes HCL? That's the Stockholm Syndrome, right? Where you got so used to writing HCL that at some point you start liking it. So there are different opinions on HCL. Some think it's the best thing since sliced bread. Others are more like, this weird thing that kind of limits myself. On the other hand, HCL also got more powerful. You have loops nowadays, and you can do more things than you were able to do at the very beginning. But yeah, to write, the code that you write for Terraform is HCL, which kind of looks like JSON without the commas in a very coarse-grained way. So that's what you get out of that. And then there are tons and tons and tons of providers. So almost whatever service you want to run, there is an integration to instrument or automate that service, from the big cloud providers to many other small things. Which then leads us over to Elastic. Like we said, I've been working for Elastic for 7.5 years or so. Luckily, finally, we picked up on using Terraform more. Those who have never heard of Elastic, maybe you've heard of Elasticsearch or Kibana or some of our other products. This is approximately what our stack looks like in a very short way. We started in 2010 with the products, and we accumulated a lot of ways to install software or do things. And I updated this today, and I hope this is the correct state. But there are many ways to get or use our software. So there's a deb package, an RPM, a zip for Windows, a TAGZ. We had an MSI at some point. We stopped doing MSI. We have, of course, Docker images. Depending on the thing that you download, it will run on different platforms and different architectures. We are not doing Docker Compose anymore. We are not doing Helm charts anymore. We only do Kubernetes operators, since the others were more like getting started things, and we want to focus more on the production side. If you were into automation in the, I want to say like the classic way, then we have Chef, Puppet, and no longer Ansible. And Chef and Puppet also have some asterisks to themselves, how well they are maintained. And then we have a cloud service and a serverless offering coming up. But the installation surface is huge in any case. And it's kind of like a way of focusing on the most important things. And Terraform is the thing that hopefully allows us to focus. So why Terraform? It's pretty much a given for any cloud service. It has a lot of momentum. And, well, we have actually created two different providers. So we have a cloud service. You can instrument that cloud service with our Terraform provider. We also can instrument the rest of the stack with Terraform. Since all of our tools basically have an HTTP API, it's very easy to configure Elasticsearch and Kibana itself through Terraform, which is a separate provider. Which also makes sense because you can also automate your own, like if you run it in Docker or any other way you have installed it, you can still configure that through the stack provider. So we have the cloud provider and the stack provider. And those two you can run to configure your services. And we actually do a lot of stuff in Golang, so that kind of like fit pretty well. Just to give you a very quick example of what that might look like, most of you who have seen Terraform, this will look very familiar. So we can just say like, I want to create a cluster in GCP Europe West 3 on the current version on that hardware type, and I want to have an Elasticsearch and a Kibana node. And then you could make it slightly more complicated and say, I create a second cluster and I actually connect the two. So this one here could also run in a totally different region, and then we could just query across those two. And this is how you could create two independent clusters so they can talk to each other. And then this also very nicely ties into the command line. So for example, I like to use envchain. Who has heard of envchain or who is using envchain? Nobody? Okay. So what envchain is doing, it's basically, everybody knows environment variables. This kind of like makes environment variables selectively available. So only when I put in envchain EC, and EC is my Elastic Cloud namespace basically, I only expose the Elastic Cloud credentials that my Terraform provider is using if I add envchain EC. Or I also have the same for AWS. The advantages are, A, you could have multiple environments. So you could have multiple sets of API keys for the same environment variable. And depending on the context, you can switch between development or production, or you could add, or that is one thing. The other thing that you can do is the environment variables are normally available to anything that runs. With this, it only makes them available when you call it with envchain EC. So if you dump, or if a program dumps all the environment variables, it will not automatically get your secrets, but only the ones that you expose. That's why I really like envchain, because different environments and kind of like managing my secrets a bit better is much more convenient. You just need to remember to always type envchain and then the namespace. For example, on Mac though, you can still see them in the keychain, and you can just look up all the envchain environment variables that you have set. There's more of a side note, but I find it very convenient to configure that. So for example, for the Elastic Cloud provider, you need an API key, and I'm only exposing that through that here. The other example here that is kind of convenient is I'm storing, so my Terraform provider has an output that I store in JSON, and I store in a variable output, and then I extract from output with JQ, the JSON command line tool. I basically extract a couple of values, like the endpoint, the username, and the password. And then I don't even need to know the specifics here anymore, but I can grab those from the Terraform output directly, and then can, for example, query my cluster. So I can access whatever I'm doing, and I don't need to copy paste like the username and the password and the long URL for the cluster, but I can just access them in ways like this, which makes handling a lot easier if you spend a lot of time on the command line. So this is also more of an aside, but this makes, at least for me, handling things with Terraform a lot easier. The second thing that we have is the stack provider, where we basically say, I want to configure my stack, and this is how to reach it. So ideally, you have a username and a password and an endpoint where you talk to that, and then you could do something like, I don't know, I want to set an ingest processor or a grok pattern to parse your log messages. And you can automate all of this. You could automate creating users, setting cluster-wide settings, creating an index, configuring something in Kibana, all of those are exposed through the stack provider, so you can configure that. And this will work for your own on-prem clusters or a cloud deployment. It doesn't really matter as long as you have the right variables here, it will do the right thing for you. One hack, since sometimes Terraform, or not sometimes, unfortunately Terraform doesn't keep up with all the APIs that we have or hasn't caught up yet. Sometimes you need a hack because the Terraform provider doesn't provide an API yet. So what I'm doing here is I'm using local exec to actually call a curl command manually. And yes, this is not pretty, but it is a hack to basically break out of things that are not implemented yet. And what I'm doing here is I'm importing a dashboard. So I've exported a dashboard somewhere, and I want to load this dashboard into my Elasticsearch or Kibana instance to make that available. I can also just reference the file here. And by the way, what is the other nice trick here is I'm taking the file, I'm hashing it, and the trigger is this hash. Who knows what this is doing and why? Yeah?
So you want a response?
Yeah.
It takes the hash and if the file content changes, the trigger changes, and so this is executed again.
Yes, exactly. So if I run Terraform apply and my dashboard is the same, it doesn't do anything. This is kind of like not what Ansible normally does, because in Ansible normally what you would do is, or depending on how you structure it, it would often run the same command many times. In Terraform, ideally you figure out that how things change and you only apply them if things have changed. So only if my dashboard ND.json has changed, then I actually re-import my dashboard, otherwise it will just skip the step and make it faster. So this is another nice hack. And then we have other providers. So for example, Azure has its own, so you see this is in the Azure namespace, they have their own Terraform provider for Elastic Cloud. So it's not just us doing Elastic Cloud, but everybody has many different providers. And Azure has a full set of all the services available on their cloud, and Elasticsearch is one of them, so you could also use this one. And then there is this other topic, licensing, which, so that Elastic hard Terraform might be a bit misleading after the licensing. That was not the intention. I submitted the talk long before the relicensing. This was just a coincidence. But like you say, when life gives you a lemon, you make lemonade. So we have a new topic to cover, so I wanted to jump into that quickly. Who is generally aware that HashiCorp changed the license? I think Hila already asked that, so I guess everybody is aware. They changed from the Mozilla license to the business software license, which has surprisingly two different acronyms how people use it. Oftentimes it's just abbreviated BSL, but BSL is actually taken, I think it's called the Boost software license for the Boost C++ library. So that's why the official terminology is BUSL, though a lot of people still refer to it BSL. Don't be confused by that, but yeah, it's a different license. And it's not an OSI-approved open source license, which made it pretty controversial. Who is concerned by the license change? Okay, quite a few. Then the next question is why? Those who raised their hand, anybody wants to say why? Yeah, sure.
Well, sorry.
Sorry. Yeah, we need the.
We're using Nomad by HashiCorp to deploy services for our customers, and we are pretty sure that this falls under the changed license model, and our legal team is in contact with HashiCorp to clarify.
Okay. Right. So you're not concerned about Terraform specifically, but
yes.
Nomad?
Yes, yes.
Okay. But no concerns about Terraform, or?
Not so much. As we understand it, most of our Terraform code is hosted at our customers, and we are working with them on their code, so it's more or less not our problem.
Right. Okay, good. That is interesting, because it's actually interesting that I feel like most of the discussion is about Terraform. I've heard very few complaints about Vault or Vagrant or Nomad. Okay, this is a special case, but that's a totally valid point, I guess. Do you regret picking Nomad?
For other reasons than the license.
Okay. I just wanted to ask, like, if just the licensing or other reasons. Okay, good. I guess that's a good discussion topic for beers afterwards.
Yes.
Anybody else wants to add anything who raised their hand about being concerned about the relicense?
That they're making a fork is kind of stupid, just because now we have people contributing to 2 projects. It's just frustrating.
Okay, so you're less concerned about yourself, but more the ecosystem.
The future, and just disappointing for the open source ecosystem. Yep.
Okay, anybody else? No? Okay.
I wouldn't say it's stupid that they created the fork. I understand why, and yeah, anyway.
Yeah. Yeah, I think there is never a perfect way to do it, neither in timeline, nor in communication, nor in executing, but yeah.
I'm more frustrated at this situation.
Yeah. So, who has heard of the fork OpenTF? Okay. So for those who didn't hear about that, so there is a fork now. At first, there was a group of companies and individuals that got together and started OpenTF, and they basically demanded Terraform. They were only concerned about Terraform to get back to an open source license. And they set a deadline and said, like, if you do not relicense to an open source license, we will fork. I don't think they got a response, and they forked in the end and ended up with OpenTF. And there seem to be very different opinions on that. I've seen some people who are either have some skin in the game or are open source friendly out of principle, who are very positive on OpenTF. I've also seen some very negative comments on that. I don't want to go through this entire Twitter thread because it has 75 tweets. But this is a great read that is going through everything why OpenTF doesn't understand Terraform, doesn't understand the users, and they don't have a seat at the table, or they don't even know that there is a table. So that post has a lot of very good points. It's basically summarizing that they did fork the Terraform main repository, but part of what Terraform is are all the providers around it. So it's much more than one repository, and everybody is just focusing on that one repository. And they keep saying, or OpenTF I think has been saying that they want to stay compatible to to Terraform itself, where I'm like, I kind of doubt that as things are progressing. I've been in a similar situation, and it doesn't work out like that exactly, and I've also seen relicenses from the inside. So I'm kind of doubtful about that. I think the other point they have is that they don't think that OpenTF has the resources to make this work, because it's mostly some very small companies who have some interest, but they are probably won't have the resources to carry this very far. There are some other consultants and individuals, but also they will not get it very far. And the other thing is that the strategic direction or where they want to go will probably not align, because there are some providers that want to have like Terraform as a service, and others who mostly want to have an open source service, and like the directions they want to go or what they want to focus on is very different. And the final point, I think what OpenTF was mostly promoting initially was that they implemented 2 or 3 features that HashiCorp has intentionally not implemented for a long time because they thought it was a dumb idea and they had reasons not to do that. I think like the encrypted state of Terraform files was one of them, where HashiCorp had its reasons for not doing that. And OpenTF implemented that and said like, oh, we're so much better and we're doing this. And this thread also covers quite a few points on why that is maybe not a good idea, or why you should have more context from the people who built this over the years than just throwing code at the problem, because code is not always the solution to everything. But it's a great thread if you want to see how that's going. I'm actually curious and want to dig this one up in like half a year or a year to see how it aged and how it developed over time, and if that is a net positive or negative. Is anybody thinking about moving to OpenTF? Just out of curiosity. One? Out of principle, because it's open source, or for a other specific reason?
I think that I am as a Terraform user.
Sorry.
Sorry. As a Terraform user, I really expecting some features. I'm waiting for a very long time. So I believe in the future of OpenTF. I have a more future that I'm working with Terraform on the daily basis, and some terrible thing not in the mainstream. So that's I'm expecting.
And Terraform just didn't have the features, or there were commercial features?
It's a lot of discussion. It's not deployed yet, as you have mentioned. So that's something that my team job is terrible. So I believe that in the future, OpenTF have more people, and yeah, it's open. It's easy to implement new feature for that thing. Yeah.
Okay. Yeah, I'm curious how it will go with the bigger ecosystem, because I think the provider registry is the big asset that
there's a
HashiCorp
lot of
has.
problems, but we will say, and I think that it can be resolved. It's all about technical things, so from a point of view, it's possible.
I'm just not sure that HashiCorp has a big incentive to resolve them.
Yeah, maybe.
I mean, obviously I cannot speak for HashiCorp, but
Sure.
I think it will be complicated, but nobody knows what the future holds.
Yeah, I'm also concerned about the future of some provider, because it has a cop on top of them, and we have a lot of providers and modules. And the question is, what the future of for example, I'm the contributor of some provider. What could I do? And sometimes I think that's very tough situation to think. But yeah, in principle, I think that it's better to move to OpenTF, and my team is discussing that right now. Yep.
Okay.
For your information. Thank you. Oh, I'm trying my best.
Any other questions or comments so far? No? Cool. So to wrap up, I hope I gave a bit of an overview why Elastic and Terraform, and why we think Terraform is great for us. And this started mainly before the relicense, but we don't feel affected by the relicense. So the way we're using it, it shouldn't make a difference. I have not heard of us thinking about actively supporting OpenTF if there are any breaking changes between them. I think that will be the long tail to see if either that API is stable enough that everything keeps working, or it starts diverging and then things will get complicated. But yeah, licensing is never a fun experience, and I don't envy the HashiCorp folks around this one. And finally, because I think you're a bit of a different audience, but I know a lot of developers who are like, oh, we can click this together in Kibana in 3 minutes. Why would I automate this? And I'm always trying to explain that once you do something a couple of times or need to have something reproducible, you probably don't want to click it together. And that once you have started to automate, it's almost like a drug that you cannot stop continuing on. Yeah. That's it for me. A, take some stickers, so I don't have to carry them home anymore. B, any other questions? If not, thanks a lot, and enjoy some more coffee.
Thank you.